Okay. Before I start, somebody has told me that this talk was one of the talks selected by the community. So I want to thank you all for giving me this chance to share this stage with so many smart people that have spoken and will speak. So, yeah, you can clap. Okay, now let's see if you all made a huge mistake. Okay, what the hell is fiber and why should I care? So first of all, a little bit about myself. My name is Fatos Hoti. I'm from a very small town in Croatia called Pula. If you haven't visited, please do. I highly recommend. And I'm currently working in Berlin, Germany as a software engineer in Clara. Clara is a fast-growing startup which has as a mission to solve the problem of communication between patients and doctors. And I usually have a tendency to speak on this kind of things about things that are not really production ready. So in that regard, this is a screenshot from a website called isfiberreadyyet.com. So you can see the answer. Not quite. Okay, what the hell is fiber? So there are a couple of answers to this question, and one of them is it's React 16. A better answer to that question is it's a new React reconciliation algorithm. And if this phrase, reconciliation algorithm, doesn't ring a bell or it doesn't give you much, maybe this will. It's a new version of React where internally everything changes, but the API still remains the same. So I have a trademark on this, just for you to know. Yeah. And this is also a fiber. Why? We'll see. So now if the talk was called What the hell is fiber, it would have been a 2-minute talk and we will be done. But the talk is called What the hell is fiber and why should I care? And maybe a more precise title of it would be Why I think you should care. Because this is a good time as any to mention that I don't work in Facebook. I'm not a part of React team. And this whole talk was created as from a perspective of an observer from outside. So everything that I will say here is just my findings across time. So to know why the hell do we need a new reconciliation algorithm, let's first see how the current one works. And for that, I want to take you a little bit back, around 4 years back actually, and to a place where React was initially released. And the first buzzwords that kept on coming when it was released were virtual DOM and diffing. I don't know if you remember that, but at that point everybody was virtual DOM this, virtual DOM that, diffing this, diffing that. Well, this diffing, this is the reconciliation algorithm. Like, this is what happens when React currently tries to calculate the difference between your previous state and your current state. Virtual DOM is just nothing more than a tree of elements which is kept in JavaScript and then applied to the DOM. Somewhere around React 14, you remember that all of a sudden we had to install 2 packages. Like, you had to install React and React DOM. And that was a tipping point where a clear distinction was made between the reconciler and the renderer. And the renderers are pluggable. So now we have React Native, React VR, React A-Frame, which are all pluggable renderers, but there's only one core algorithm, and that's React. So there are a couple things that I hate in life. One of those are to-do apps. So my example will be a to-do app. And I will call it a useless app during this example because it basically does nothing. It has 3 items and a button that says mark odds, and when you click it, the odd items get marked. So it's pretty useless. So how does the current algorithm work? Can you see this? Okay. So how does the current algorithm work? So React will go on each and every node and recursively call render on it, see if it needs changes, and then call render on it. So first, what you will have on top of your tree will be something called the host root, which would be a div where you rendered your app, something like div ID app, root, home, whatever you call it. Then most usually you will have a wrapper, which would be a div which would hold all your components inside. Then the first child of that wrapper would be a list. That list would have 3 children. It would be to do items 1, 2, 3. And the second child of the list of the wrapper would be the button. And if you check out your React tools, if you make a recording of this in your dev tools, it would look something like this. It would be a bunch of recursive calls going down, and after that, unwinding to the top back to React. Unlike the current stack reconciler, Fiber reconciler in the DevTools looks something like this. And why? Well, the whole talk is basically about that. So Fiber splits work into units of work. Oops, sorry. Into units of work, there's a basically tree or subtree chunks, computes the changes, and schedules their execution. And it does that with the help of 2 APIs called request idle callback and request animation frame. So I presume that most of you have heard about request animation frame. So it's scheduling work before the next frame, so 60 frames per second, every 16 milliseconds. While request idle callback is basically your code saying to the main thread, you have this work here, do it when you have time. Like, it's no rush. Like, I'll put it here, when you have time, do it. So for Fiber to be able to chunk data and to split it into units of work, it needs to work in phases. And the first phase, the renderer reconciler phase, is interruptible. So you can interrupt in the middle of the tree and say, now go do something else, then get back. Phase 2, the commit phase, is non-interruptible. This is where React submits the changes to the DOM. And this can be interrupted. So again, let's take a useless app. And during the initial render, React Fiber will build a tree that looks something like this. So again, you can see it's not quite the same. There are some subtle differences. First of all, there's no like distinct parent-child relationship between nodes. There's only a child and a return address relationship. And as you can see, there's no wrapper around it. And you can see that list and button have a relationship called sibling. And that's because now in React we can return arrays from render. I was accepting a little bit more, to be honest. This is the most requested feature since React exists, and it's finally here. Okay. So the observant among you might have noticed what each of these nodes takes care of, which relationship it takes care of. Child, return, a sibling. And if you remember this slide, this is called the Fiber. And this is where the Fiber reconciler gets its name. While starting up, Fiber will also start something called a work loop. And for the simplicity's sake, let's say work loop is a function that has to keep track of 2 things: the next unit of work and the time remaining it has to do that work. So somebody clicks a useless button in a useless app, and the update starts. And React Fiber will start building something called a work in progress tree. So first what it will do is clone the host root because it has no changes. It will clone it and then go down the list. So if you can see here, I don't know if everyone sees here in the bottom, we will keep track of what is the next unit of work and what is the time remaining. So basically we'll be acting like the work loop here. Okay, so the next unit of work is list and time remaining is greater than 0. So React knows you can take the next unit of work and proceed. It takes a list, and at that point, list has an update queue because 2 elements have changed. And time remaining is 0, so React will say, okay, let's go and process this. It will call set state, it will call render. And how many React developers do we have here? Show of hands. Can you see anything weird with set state? So yeah, it's a function. So this has been in the docs for, I think, 3 years at this point, but not a lot of people know that you can do this. With React Fiber, you might start thinking about doing this all the time, because Fiber doesn't guarantee you the order of execution. So especially for situations where your current state is dependent on the previous one, let's say a counter app, you don't want to do it like this state equals state plus 1. You want to use the updater function, because as a first parameter, it will get the current state and then the props of your component. So let's say from 1 to 2, and then from 2 to 3. You get what I mean. OK. At that point, React will start processing the list. First thing that it will do, it will take all of its children, see if they are the same types, if it needs to tear down the tree or not. At this point, we can see that the keys in the list are the same, and that the elements are the same. So what will React do? It will copy over those values into the work in progress tree. And then it will take the next unit of work, which is to do item 1. It will process it again, and see time remaining will be greater than 0, and it will take the next unit of work, which is the div. And at this point, we reach the end of our subtree. So there are no more kids in this part of the subtree for React to process. And what it will do, div will merge its changes into its parent's changes, which is the to-do list item 1. And it will put that in something called an effect list, which is nothing more than the update list that React has to do, that it has to commit to the DOM. OK, so we have to take 2 as next unit of work and start processing it. So at this point, we are smart developers. We implemented the component should update, and our component should update looks something like if the state is the same, and if the number is the same, return false. So for the case of the unit of work number 2, it will return false, so React will know that it doesn't have to do anything, and it will proceed. The next unit of work will then be 3. React will see that there are changes, and you can see a pattern here, right? It will then go to the div. It will be the end of the subtree. It will put, again, its div and itself to the effect list, and then, as it has no more children and no more siblings to pass to the list, it will call complete on its parent, which is the list, and will add itself to the end of the effect list. OK, now that we're done with list, we will take the sibling of the list as the next unit of work, which is button. Button hasn't changed, so we are done with this, and we can call complete on the parent of all of it, which is the host root. And now, this makes more sense. When you get to see how the work loop works, how it functions, now this graph from the DevTools makes much more sense. And this is basically end of phase 1. This is how it ends. Now, React marks this as a pending commit. It's ready to commit those changes. And what it will do, it will go through the effect list, again, call some lifecycle method like component did update, and we'll call another new lifecycle method called handle errors, which is a really cool thing because you can isolate error handling on a component level now. So just imagine it that this is a try-catch around your component, which is done really smart. For instance, if you have in the handle errors set state, which will re-render the component and again fail, that error won't be caught by the same handle errors, but will be caught by the parent one. So you can't have like this infinite loop of handling errors and re-rendering. So somebody thought of that really smart. And now, the current tree is the more updated one. So it's currently represents the app state in a more better way than the old one. So React switches pointers and puts a pointer for the current tree on the X work in progress. And this is more or less the happy path. So everything went well. The work loop had enough time to process all updates and so on. But let's take a useless app and make it a bit more useless. So we will add here a button which is called Super Hyper Turbo Urgent Update. And what it will do when we click it, it will make 1 million animations using request animation frame to end up in a state where the letters are red. So you can't get more useless than this. So OK, and let's say that this is the situation. Our next unit of work was 2, our time remaining was greater than 0, and someone pressed the Super Hyper Turbo Urgent Update. So how will it happen? At that point, React will schedule this Hyper Turbo with this urgent update and via the request animation frame, and it will basically schedule it as a high priority update. And for it to be able to do that, Fiber introduces some priorities. So the priorities of updates are as follows. So it's synchronous, which basically works as the current stack reconciler. Task, which has to happen before the next tick of the event loop. Animation, which has to happen before the next frame. And all of this, high, low, and off-screen, are scheduled using request idle callback. I forgot to mention, for browsers that don't support request idle callback, React will polyfill that for you. So high priority is something that has to happen immediately. So let's say something above the fold, some sort of rendering above the fold. Low is something like data fetching, changes in Redux stores, so something that the user won't change if it has another 20 to 30 millisecond latency, 50, 100. And off-screen, that is the lowest priority possible that something can be rendered with, and that's for things that are hidden, that are below the fold, and are not critical for the user interface, for the user experience at that point. Okay. So just a quick note. I said that API remains the same. Well, that's kind of truth. There's one thing that you have to watch out now. So currently in React, there's this belief that some of the lifecycle methods will be executed in pairs, like component will mount and component did mount. Well, this is not longer the case, because component will mount, component will receive props, should component update, and component will update are all executed inside the renderer reconciler phase, while in the commit phase, we execute component did mount, did update, and will unmount. So what that means, that if we had a situation where React discarded a part of the tree while calculating it to go and do some higher update, and then got back, your lifecycle methods from phase 1 would be executed twice. I know a lot of people have the tendency to put data fetching in component will mount. Don't do that anymore. Okay. So at this point, if you are like, oh my god, this is so cool, I want to know more, there are a lot smarter people than me that have spoken about this. One of them is Andrew Clark on React Next 2016, where he explains what is the idea behind Fiber. An amazing talk from ReactConf this year by Lynn Clark from Mozilla called A Cartoon into Fiber. If you're interested in this, this is a must-see. And from React London, I don't know the guy's name, but I think the talk is called Tiny Fiber Renderer, in which it's explained what is needed to create a fiber renderer. If you want to know more about components, elements, and how this all works in React, I highly suggest the Facebook blog post called Components, Elements, and Instances. It was written by Dan Abramov, if I'm not mistaken, but I'm not sure. Implementation notes, which explain all the design concepts behind React Fiber. And reconciliation, which explains by Paul Shaughnessy, something like that. He's a part of the React core team. That explains like what is reconciliation, why some of the choices have been made, and so on. So if you want to try React, it's as simple as doing yarn add React next and React DOM next, or npm install, whatever you wish. And don't forget, Fiber is not ready yet, so don't use it in production. And thank you very much.